Okay, so what we're after is the Jacobian matrix of this. So all the Jacobian matrix basically is we look at the very first one and we look at, say, f of x, f of y, f of z, and then we look at the next one, let's call it g. So we look at the next one and we do g of x, g of y, g of z. And then we look at the last one, we do the same thing, h of x, h of y, h of z. That's all the Jacobian matrix is. And so it's a nice question. It's a question that isn't too hard to do, I don't think. So let's look at the first one. The derivative of this with respect to x is just 6. Now there's no y's here, so the derivative so that's just like a constant, 12. So what's the derivative of 12? 0. What's in terms of y? In terms of z, what's the derivative? 0, because 6x is just a constant. If we look at this one, and it's a matrix, so I'll put some matrix things around it so we know what we're doing. In terms of x, that means all of this is a constant. So let's say that is 10. 10x would just become 10. So this just becomes y to the z squared. And exactly the same when we're finding the derivative of this with respect to y, everything else is just we just assume it's a constant. So this is be like 10y. So that would just be 10. So what we get is xe to the z squared. And in the last one, everything's a constant except for the z. So we're differentiating this with respect to z. So this is just like 6 out the front. So how do we do that? We find the derivative of the power 2z times xye to the to the z squared. And then we do exactly the same for the last one. So what's the derivative of this in terms of x? 4x, 4yz. What's the derivative in terms of y? 4xz. And if we're only finding the derivative with respect to z, that means the x and the y's are constants. So this is, again, like 20z. What's the derivative? Just 20. So in this case, it's 4xy. And that's all the Jacobian is. So a nice, simple one. Hopefully it's something that everyone can get pretty good marks with, that one. Okay, thanks.